Hi. So for this problem, we are given an array and a number k, where k is the smaller than the size of array. We need to find the kth smallest element in the given array. It is given that all array elements are distinct. So suppose we have an array is given like 3, 2, 10, 5, 6. So we have, and k is 3. So we have to tell that what is the kth smallest element in this array. So first of all, we'll see which one is smallest. So 2 is smallest, then comes 3, then comes 5, then comes 2, 3, then 5, then 6, and then 10. Okay. So we have to tell the third smallest element. So third smallest number will be 5. So answer will be 5. So basically what we did is we first sorted the elements, and then we found the third element in the array. So by saying sorting, so the first solution, the easiest solution we can solve this problem is by using sort method. So there are different ways to sort. So we can use any sort method and then just find, and after it's sorted, then it's just easy to find. Like we can write the k minus 1 array of k minus 1, because array starts with 0. So if we have 3, so it will be k minus 1 equal to 2. So that's second position. So suppose it is sorted now. So second position, 0, 1, 2 is 5. So we'll return 5. So this was all about sorting. So but here we are gonna do using heap. So heap is basically I'll write it somewhere. So heap is basically a binary tree which has 2 child, but heap there's 2 types of heap sort: max heap and min heap. So in max heap, root is the largest. Root is the largest element in an array, and parent is greater than its child, both its child, left or right. In case of min, it's totally opposite. Root is smallest element, and in this case, parent is less than child. Whatever the value of parent node is less than child. So and max heap is used. By using max heap, the array will be arranged in an ascending order, and that's what we needed to arrange this array for, because we need the kth smallest. We can also do it by min heap, like decreasing order, but increasing is fine. So max heap. So for this problem, we will be using max heap. Yeah. So before coming to this solution, I'll explain this problem with an example first. So suppose we have this array. Okay, 4, 10, 3, 5, 1. So the first and foremost step for this problem to solve this problem is to build a heap. So we will how are we gonna build the heap? So it is simply 4 will go to the root, then 10 is the left child, 3 is the right child, then 5 is the left child, and 1 is the right child. So the heap representation of the given array will be this. And if there is there is one more property of heap, like the end will be always in the left. Like suppose, like if we have just one element in at the leaf node, like here there is one more element, so we are gonna put at the leftest end. Okay. So anyway, so this was the heap, we build heap. Now we have to transform this heap build to max heap. So to transform max heap, so first of all, we'll see compare parent and its child. So here parent is small and 10 is also the largest. So the first and foremost step was to bring the largest element at the root. So this is also the parent-child relation, and it also happens to be the largest element in this array. So we'll bring 10, we swap 4 and 10. So 4 comes here, 10 goes there, and our array now it will look like 10, 4, 3, 5, 1. Only these two are swapped. Okay. Then we will see, in this case, 4 and 5. 4 is smallest, parent is smaller than its child, so we will swap these two as well. So 5 will go here, 4 will go here. We will also swap this in the array, 4 and 5. So our array will now look like, okay, I did 2 steps, one at once. So here it will be 10, 5, 4, 10, 5, sorry, 3, because we always just read like this. So 10, 5, 3, 4, 1. So this is for this step, okay, by interchanging 5 and 4. Then once it is converted into max heap, once the max heap is done, then we will swap first and the last element. So we'll swap 10 and 1. So 10 goes here, 1 comes here, and delete the last node. Okay. So here we have to so basically we build from an array we build a heap first, then we'll convert it to max heap, and then once it is converted into max heap, we'll swap first and the last node and delete the last node. After swapping, then we are gonna delete. So let's see here. So in this case, 10 and 1 will be swapped. So 1 goes here, and other elements will be there. 10 here, and 10 will be deleted. So now the array will look like 1, 5, 3, 4, 10. In the array, we'll of course write 10, but in the heap representation, it is deleted. So it means like 10's position is fixed now. We are not gonna do anything with this last position of this array, which is 10. Okay, so now again we have to build the max heap. So again here is 1. So 1 is like it is also root and it is maximum. So it will go there, and also it is parent child. So 5 should be at the parent or root, whatever, because it is parent as well as the root of this node. So we will swap 5 and 1. 5 and 1 is swapped. So 5 and 1 is swapped. So now it will become 5, 1, 3, 4, and 10. 10 is permanent, so we are not going to touch this. We just keep right 10. Okay, so now 1 comes here, so now this is like ruined and we have to fix this one. So 4 goes there, 1 comes here, so we'll swap 1 and 4, so 5, it will come 5, 4, 3, 1, 10. Okay, so now it is max heap, everything is fixed. Now we'll swap first and last and delete the last node. So 1 goes there, 5 comes here, 1 goes there, 5 comes here, and other are there only. So 1 and 5. So we'll write 1, 4, 3, 5, 10, and then 5 is deleted. So now we have 1, 4, and 3. So now 1, 4, and 3. So it is already a max heap because we can see that parent node is the largest node and 3 is the child and 1 is the smallest. So we'll directly come to the steps swap first and last node. So we'll swap 4 and 3. 4 and 3. So 3 will go here, 4 will go here, 1, 5, 10 will be at their same places, and then after it is swapped, we'll delete the last node, which was 4. Now it's 3, 1. This is also a max heap because parent is larger than its child. So we'll swap this and delete the last node. So 1 will go at this position, 3 will go here, and it was 1 and 3. So 1 will go here, 3 will come here, 4, 5, 10, and we'll delete 3. So now 1 is left. So now it is done, and we can see that it is arranged in ascending order. And to find the kth smallest, we can just return k minus 1, array of k minus 1. Okay, so this is, so now programmatically we are going to see I have a class max heap, and then I'm also writing a function called sort. So this is sorting. So this is length and then heapify. So the heapify is basically creating the max heap. Heapify is creating the max heap, and this here it creates the max heap in the reduced array. So every time the array is getting reduced, so here again I'm calling heapify and it is reducing the array. And this swap, there was swap function. Okay, so this is and this heapify is creating the max heap. Here it is sorting, and then here is the kth smallest. So I'm doing this one. Okay, yeah, swap is here. We are swapping 0 and ith. So it is here. So this is how the this kth smallest element is solved using heap.